really don't get that much precipitation. No, it doesn't matter. But you get no precipitation. Period. And then we have the polar. So Arctic is above polar.
You said that, right? So some parts of Russia and stuff like that, they don't get
Well, they get very little. That's pretty much snow. Now, our continental polar guys, when we get those, remember we had, think back to right before spring break, we had those 2 weeks of really awesome weather, right? And that's because this air mass, maritime tropical, moved in, and we had a lot of warm air being brought up from the south. And it was coming from that maritime tropical. And immediately after that, what do we do? Yeah, we just like shot right down into the 30s again. And that's because as this air mass started moving out, the polar air mass started moving in. And brought with it those very, very cold temperatures with it. You know when the polar air mass is coming in? Because all of a sudden we go from 70 degrees down to 50. Alright, so that's usually telling you that that polar air mass is moving in, bringing with it all that cold air with it. And then we have this tiny little region right here, which is CT, which means continental tropical. Again, all tropics tells you it's going to be hot. Continental tells you it's going to be dry. So typically we have deserts that are associated with the continental tropics. So those are your different types of air masses that we have. So each one of those, like I said, that's basically when we look at our climate, and we look at ourselves right here, we honestly have two air masses that kind of work together for our climate. That's why we actually have very mild winters here.
You also get the maritime polar.
That would have to be a very strong maritime polar. To bring in the maritime polar that far, and it has happened, that takes a lot of energy. It's going to be a major system to be able to bring that all the way across the United States. Because you also have to remember, in between us and the maritime polar is a set of mountains. Okay, so it's got to be strong enough to get up and over those mountains and bring that moisture with it. Yep. Well, yeah, and if you look at that too, you look at the Great Lakes. We'll zoom in on that. You guys ever heard of lake effect snow? Okay. Sometimes the Great Lakes actually act like a maritime polar. So with storms, that moisture gets picked up over the Great Lakes, and it dumps a ton of precipitation as soon as it makes landfall. Okay, especially right here along I-80, every single time, right? Some of the guys, when we get like heavy snow, we might get only 3 inches, but you go 15 miles north and they got 10, 15 inches.
I live right up along the border. We're 2 miles from Michigan, just south of the toll road. We can see Michigan from our backyard. You can see the rest of Indiana from the front yard, and you're accurate. There can be just a mile north of us, you get 6 to 10 more inches of snow than we get. We're right on the border, and then just 15 miles south of us, we get hardly any.
Yeah, and that's it's all because if you look right here, at the very southern tip of the lake, if you draw a line straight across, it follows our state line. So sometimes we're a little bit too far south. So a lot of times we like to follow what's going on in South Bend. Doesn't really do us any good. The South Bend sits really close to the lake, so you get a lot more of what we're going to get. So we really need to be looking at more of what's happening down in this region. And then that'll help us actually predict more of what's going on here. So that's why some of you guys have friends that are part of Fremont or the Steuben County school districts. You actually, they'll have a lot more school off than we will. Just put it that way. So that's a difference there with the air mass. Now we got a chance to talk about lake effect. Next thing I want to talk about is the Coriolis effect. This is one of those things that we start talking about with wind. A lot of students struggle with understanding. Ooh, Brandon feels like he has something to say.
Yeah, and that is on Call of Duty. They was in Call of Duty 4 Modern Warfare, and then they were in Active One. You were supposed to take out a guy and pull it, like when you were looking right at him, the other way the wind was blowing and carry the bullet at a certain height. So you have to keep an eye out on the flag and you have to aim at it.
You gotta follow the curvature there.
Well, that's more about the wind affecting that, and that's more the vectors and all that. Correlates effect does have does come into play with long distance sniper shots. When you're trying to make a shot that's over a mile away, which has been done, it's scary to say. You do have to take into effect the Coriolis effect. What I want to talk about is why does that occur?
Which has or has not
Has been done. Basically, all the Coriolis effect is, if you wanted to define it, it is a deflection due to Earth's rotation. And remember that we rotate from west to east, so we're going in an eastward direction. And the north to south, we actually do rotate in different directions. In the north, we rotate to the right.
So you're saying when you go like
No,
the poles? I remember seeing yesterday in the diagram where one thing was going the opposite way.
no, that's more for winds. What we have with us, the best way to model is actually look at a globe. And again, I'm rotating in this direction, correct? So when you look at it directly from the North Pole, which way is that going to be rotating? It gets pushed to the right. If I flip that over, you look at it from the south, I start rotating. Which way is it now moving? Moving to the left. So that's from the perspective of the poles. That's why we get different, different deflections with the different hemispheres. So the northern hemisphere gets deflected to the right. Southern hemisphere gets deflected to the left. Now, for the most part, this is something that you and I need to be concerned with. But it actually does play a role in a lot of things. If you were to simply throw a ball, that ball will have a small curvature to it. But since you're throwing it such a small distance, the curvature is almost nothing. But now you try launching a missile, or ICBM, right, Intercontinental Ballistic Missile. You can try and get that to go. You have to take this into effect. So now you're going a large distance. If you're flying a plane, you have to take that into consideration because as you're flying, and actually I'll show you this diagram here in a minute. If I'm flying, let's say from, we'll go from right here. We'll go from Indianapolis. I suppose I want to go due south to, let's say, we'll go to, Acapulco.
You can't just fly straight.
But let's suppose I wanted to do that, just go straight south, right? But as I'm flying, what's the Earth doing underneath me? It's rotating. So as I'm flying straight south, actually it appears I'm getting, as I'm heading south, it looks like I'm getting to deflect to the right. Okay? So that's kind of what we're talking about. Now, again, if you're going up the other way, as I'm going north, which way am I getting deflected? So I'm actually getting deflected to the left. So again, it depends on the perspective you're coming from. And so that's what we're going to talk about here. And we'll see that in this next slide. So, in here we have, we're starting up here in Alaska, trying to get down to Miami. And as I'm flying, the Earth is actually rotating underneath me. So if I just stay that path, I'm not going to get to Miami at all. So you have to take into consideration Earth's rotation and make adjustments to your flight plan because of that. So in fact, what they actually do is they overcompensate. And so what happens, their actual flight plan will actually look like this. You're going for there. and then by the time they actually get to Miami, that's where they need to be. By the way, as long as we're talking about flight plans and stuff, you guys ever look at a flight plan? Have you guys ever flown before? Just a couple. Okay, usually within the seat in front of you is a little book that shows all the different flight plans. Suppose I wanted to go from New York to London. Where does the plane go? Do I go straight across? No, they actually come up and down. It's actually shorter distance to go up through the north and come back down than to go straight across.
Let's see what you're talking.
So, when I look at the Earth, I mean, it's a lot of complex engineering to take into consideration. There's a lot more going on in our world than you would probably ever thought about. So here's another demonstration of the Coriolis, this time going to the north. When you go to the north, you get deflected to the left. Okay, so that's the Coriolis effect. What? Ooh, that's a great question. I have no idea.
What's the question?
Great question. Does the Earth rotate independent of its atmosphere?
Yes.
Yes.
The atmosphere kind of, you could also think of it as the atmosphere standing still and the Earth's rotating underneath it.
Freaky.
Right?
Ooh, better question. Talking about theory of relativity. If you're driving down the expressway, are you moving or are you moving the Earth?
You're moving on the Earth, which is moving.
Oh. That's the whole concept of theory of relativity
Depends where you
am
are.
I staying still or is and making the Earth move from underneath me and drawing that piece toward me?
Depends from your perspective.
Yeah, it's crazy. You guys gotta read some Einstein work. Crazy stuff. Now, this Coriolis effect actually plays a big role when we talk about our global wind patterns. And that's what we're going to get into next. We kind of saw this one already. But that's why our winds get deflected in different directions. So when we look at it in the north, those winds are getting deflected to the right. Oops. And then in the south, they're getting deflected off to the left. And so that's kind of where we actually get those major wind patterns coming from, is due to that Coriolis effect. Okay. So again, we're seeing that deflection in the north, to the right, and deflection to the left and the south. All right, the last thing I want to talk about today are where these wind patterns are located.